Hi, in this video I present the application of QSWAT model as a class exercise where I try to learn the ropes of hydrological modeling. I developed this exercise for the Pereira River basin located in Colombia. This basin has a water resource management plan formulated by Corpus SART, the environmental authority. On the left, you can see the information related to the water quality, risk scenarios, availability. On the right side, you can see the different control points marked on Google Earth Pro on the study area. Well, proper processing, organization, and preparation of the model's inputs data is a fundamental step that will help make the modeling process more effective and avoid going back to square one. Having information, watershed, boundary, drainage, network, land use, soil, and climate organized in a folder with a clear and easily identifiable names optimizes the process. As you can see in the screen, these are the different sources and the process that I try to run. After processing the information, the project is created, as you can see in the screen. The model step-by-step process begins starting with the delineation of the watershed. The input information for this is the digital elevation model, the drainage network, and the discharge point. On the left side, you can see the watershed has elevation ranging from 123 to 3,400 meters above sea level. After entering the input layers, the resulting sub-watersheds are obtained. In this model, there are 39 sub-basins. This is the hillshade, and these are the sub-basins. The second step of the model begins with the entry of land uses and soil types. Approved land uses are presented on the left side of the screen, where the predominant use is deciduous forests, followed by agricultural use crops, as you can see. And regarding soil type, the predominant one is the acrysol. The acrysol is the most common soil type in the screen in blue color. The next step is to create the hydrological response units, which are the combination of unique land use, soil, and slope characteristics. If we made it so far, it's because we are doing well. Now, let's edit the inputs in SWAT+. To do this, as is shown in the video, we have to select the data source. So this data source either imported directly from the default information provided by the model or for information obtained for the study area. This applies to both the climate data of the stations. As was mentioned in slide 6, for the Pereira River model, we are using information from the area provided by the University of Guelph in Canada. The process takes time depending on the processor that you have in your computer. In the video on the right, I do some codes to have been made to hit the ground running. The final step is visualizing the results. Here, in this step, you can make different variations on the output tables. You can create animated maps that can then be exported in GIF format. Just like the ones that appear on the screen after selecting variables such as inflow or outflow, among others. This visualization allows me to plot graphics for the basin's channels. As the model shows, this basin has 293 channels, 93 channels. The channel that coincides that match with the discharge point is number 73. So I select it and plot the outflow. While I continue to show the visualization of the results in the video on the right, I like to highlight some of them simultaneously on the left. Here you can see the longitude statics. In this other, the simulation parameters reported by QSWAT. In this other one, the schematic representation of the water balance. And in this one, you can see the animated GIF maps of the inflow and outflows of the basin. The Pereira River basin was modeled using QSWAT. It is noteworthy that the process was simple in terms of adapting the input data and be carefully following the steps. The results were visualized. On the left side of the screen, some points discussed during the class with the professor and colleagues are summarized. Finally, to get the hang of it, QSWAT modeling calibration should be complete, even if just something that allows us to go the extra mile. Additionally, for future models to turn over a new leaf, I will try to obtain first-hand information. Thank you so much.